This question number 13. Prove that opposite sides of a quadrilateral circumscribing a circle. I have already made a figure here. The quadrilateral is A, B, C, D, which circumscribes a circle, and then there are 5 points of contact P, Q, S, T, and I have also joined B, O, OP, and all those lines which you can see here. Now, first we need to know about what is supplementary and what is complementary angle. So whenever two angles add up to 180 degree, it is called supplementary angles. So this is what we should remember. And complementary, by the way, is when the two angles, when added together, makes 90 degree, then it is called complementary. So here we need to stick to supplementary angle. And then for solving this problem, by the theorem, we know that these two angles subtend equal angles, okay, here, because triangle BPO and OBT are congruent, and the same case with this one, and this one also. Okay, so we will take advantage of that, and in that case what we can say that if this is angle 1, this will also be angle 1, because these two are congruent. And if this is angle 2, this will also be angle 2, because these triangles are congruent, isn't it? Similarly, we can say that these angles, we can name it 3, are the same, and these angles are also the same. Okay, so now what is the angle subtended on the center of the circle by BC? It is BOC, isn't it? And then what is the angle subtended by side AD? It is angle AOD, isn't it? But this BOC is equal to 1 plus 2, angle 1 plus angle 2. And then on side for the angle AOD, it is a summation of angle 3 plus angle 4. Okay, so what we will get when we add these two, because after all what we need to consider is addition of these two angles which are subtended by opposite sides, and BC and AD are opposite sides, isn't it? So we get summation of all these 4 angles, which we need to prove that it is 180. So now how we will do that? We can very well do that. We can do that, because we know that for any two lines which are crossing each other, sum of all the angle will be 360 degree, isn't it? This we know. And similar thing is happening here also. You see, if we add all these angles, it will be 360 degree. But what are all these angles? We know, we have already named angle 1, and then angle 1, then angle 2, 2 times, then angle 3, 2 times, and angle 4, 2 times. They all sum up to 360 degree. So we can also take out 2 and then say that, okay, 2 is common to all. So we can say that these 4 angles put together is 360 divided by 2, which is 180 degree. and this is what we need to prove here. Okay, so it was a very simple question, but we need to know the theorem, and we need to know that these triangles are congruent to each other. All the set, this set, then this set were congruent, this set is also congruent, and this set is also congruent. So this is how we solve this problem.